Everyone, welcome back to my YouTube channel. I am Bhumikavi, pursuing my computer science and engineering from Sri Venkateshwara College of Engineering, Bangalore. Today, I am here to explain the topic definition for gradient, directional derivative, curl, and divergence. Let's move on to the topic. First of all, let us know definition of gradient. Gradient in mathematics, a differential operator applied to a three-dimensional vector-valued function to yield a vector whose three components are the partial derivatives of the function with respect to its three variables. The gradient is often referred to as the slope m of the line. The gradient or slope of a line inclined at an angle theta is equal to the tangent of the angle theta, where m is equal to tan theta. The gradient can be calculated geometrically for any 2 points such as x1, y1 and x2, y2 on a line. Consider an example of gradient where gradient slope formula is used and the formula is given as m is equals to y2 minus y1 by x2 minus x1, which will be equal to delta y by delta x. So m is equal to 6 minus of minus 2 by 2 minus of minus 2. When we simplify, we get m is equals to 8 by 4. When we divide, the answer will be 2. Let us know the physical interpretation of gradient. Using the language of vector fields, we may restate this as follows. For the given function f of x, y, gravitational force defines a vector field f over the corresponding surface z is equals to f of x, y, and the initial velocity of an object at a point x, y is given mathematically by minus lambda f of x, y. The gradient also describes directions of maximum change in other contexts. For example, if we think of f as describing the temperature at a point x, y, then the gradient gives the direction in which the temperature is increasing most rapidly. Gradient of a scalar field. The gradient of a scalar function f of x1, x2, x3 so on till xn is denoted by nambla f, or where nambla, the symbol, denotes the vector differential operator del. The notation grad of f is also commonly used for the gradient. The gradient of f is defined as the unique vector field whose dot product with any vector v at each point x is the directional derivative of f along v. That is, lambda f of x dot v is equal to dv f of x. In three-dimensional Cartesian coordinate system, it is denoted by lambda f is equals to I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou z, which will be equal to dou f by dou x into I cap plus dou f by dou y into j cap plus dou f by dou z into k cap. Let us know about directional derivative. The formula for the directional derivative is f of p dot u, where u is the unit vector and f of p the gradient at point p. The directional derivative formula in the direction of a vector u at a point p is given by f of p into u, which means the multiplication of function f at point p with the vector. A directional derivative represents a rate of change of a function in any given direction. The gradient can be used in a formula to calculate the directional derivative. The gradient indicates the direction of greatest change of a function of more than one variable. Divergence and curl. In mathematics, divergence and curl are the two essential operations on the vector field. Both are important in calculus as it helps to develop the higher dimensional of the fundamental theorem of calculus. Generally, divergence explains how the field behaves towards or away from a point. Similarly, curl is used to measure the rotational extent of the field about a particular point. Let us know more about divergence. In vector calculus, divergence is a vector operator that measures the magnitude of a vector field source or sink at a given point in terms of a signed scalar. More technically, the divergence represents the volume density of the outward flux of a vector field from an infinitesimal volume around a given point. Divergence of vector field. The divergence of a vector field is a scalar field. The divergence is generally denoted by div. The divergence of a vector field can be calculated by taking the scalar product of the vector operator applied to the vector field, that is namla dot f of x, y. So the formula can be given as f is equals to f1i plus f2j plus f3k, which will be equal to f1, f2, f3. Therefore, namla is equals to dou by dou x into I plus dou by dou y into j plus dou by dou z into k, which will be equal to dou by dou x, dou by dou y, dou by dou z. So the actual formula will be given as divergence is equal to namla dot f is equal to dou f1 by dou x, dou f2 by dou y, dou f3 by dou z, and the formula for curl is given as namla into f is equal to modulus of I cap, j cap, k cap, dou by dou x, dou by dou y, dou by dou z, f1, f2 and f3. Curl of a vector field. The curl of a vector field is again a vector field. The curl of a vector field is obtained by taking the vector product of the vector operator applied to the vector field f of x, y, z. That is, curl of f of x, y, z is equal to namla into f of x, y, z. So the formula is given as curl of vector is equal to modulus of I cap, j cap, k cap, dou by dou x, dou by dou y, dou by dou z, 2x square, 3z square, y cube. Thanks for watching. Please do like the video and subscribe to my YouTube channel.